Ladies and gentlemen, today I'll be presenting on phases. On phases today, I'll be discussing electromagnetism. On electromagnetism, I'll also be discussing electricity or electric circuit. On electricity today, I'll be talking about power dissipation in parallel resistance circuit using the Ohm's law to solve our problem. On this note, ladies and gentlemen, I was told that electromagnetism is a branch of physics that deals with a relationship between electricity and magnetism. And I was also told that electricity is the flow of electric charges, usually electrons, through a material like a wire. On this note, ladies and gentlemen, I was told that the Ohm's law was introduced by one of the greatest physicists today, called John Simon Ohms. He introduced the Ohm's law specifically in the year 1827, and the unit called ohms was introduced by John Simon Ohms in the year 1881. However, ladies and gentlemen, the Ohm's law states that the current passing through a metallic conductor is directly proportional to the applied potential difference, provided the temperature remains constant. Ladies and gentlemen, based on this information given today, we'll be looking at our problem to solve. On our problem today, we have three resistors. A, B, and C are connected in parallel. A potential difference of 18 volts is maintained across the parallel connections. If the resistors of A, B, C are 3 ohms, 6 ohms, and 9 ohms respectively, calculate the power dissipated by each resistor and the total power dissipated by the 3 resistors. On this note, ladies and gentlemen, before solving our problem, we'll be looking at our diagram. On our diagram here to solve, we say this is the diagram, and the diagram is called the parallel circuit diagram. Why it is called a parallel circuit diagram? It is called a parallel circuit diagram because all of the resistors are connected in parallel, and the voltage across each resistor are the same. On this note, automatically this is the parallel with the parallel circuit diagram. On our parallel circuit diagram today, we'll be indicating all our resistors on this diagram. Remember, this is resistor A, which is automatically equal to 3 ohms, and this is resistor B on our diagram, which is automatically equal to 6 ohms, and this is resistor C on our diagram, which is automatically equal to 9 ohms. Ladies and gentlemen, and our volt here will be 18 volts. On this note, ladies and gentlemen, based on this information given on our diagram, we'll be using our data to solve. We say data. On our data today, we say resistor A will definitely be equal to 3 ohms, while resistor B will be equal to 6 ohms, and resistor C will just be equal to 9 ohms. Remember our volt, which is V will be equal to 18 volts. On this note, ladies and gentlemen, we'll be finding A, the power dissipated by each resistor, which is P, will just be equal to question mark, and B will also be finding the total power dissipated, which will also be equal to question mark. On this note, ladies and gentlemen, based on these informations, we'll be looking at our problem to solve. On our problem today, we have our formula, and our formula says P will be equal to V squared or R. Remember, this is the formula that we'll be using to solve our problem. Remember, P will represent power, ladies and gentlemen, and the unit for power is watts. Automatically becomes the U. We also have V. V will represent the voltage, and the unit for the voltage is volt. It will be represented by V. We also have R. Remember, R will also be representing the resistance, or we say the resistors will also be equal to ohms. And the unit for ohms is this sign. So on this note, ladies and gentlemen, based on this information given, we'll be looking at them to solve our problem. But I was told that the unit watts was introduced by G. Watts specifically in the year 1882. And I'm also told that the unit volt was also introduced by Alexander P. Volta in the year 1881. And I was told that ohms was introduced by John Simon Ohms in the year 1881. On this note, ladies and gentlemen, we take our formula to solve our problem. Now, formula says P will be equal to V squared. Or I remember, since there are three resistors, resistor A, B, and C, will also be making the power to be 3. Power A, power B, and power C. So in expressing this, we say power A now will be equal to V squared over resistor A. Remember, this is called the electric power formula, derived from the Ohm's law. On this note, ladies and gentlemen, we say power A will just be equal to V squared. Remember, we already have our value for V, and our value here for V is 18 volt. So what we see, we say parenthesis open. We have our volt to be 18 volt, all raised to the power 2 over 1 resistor A. And remember, resistor A automatically we give us 3 ohms. So based on this aspect, ladies and gentlemen, we say power A will be equal to, we have in a parenthesis 18 volt all raised to the power 2, means that we should multiply this 18 2 times and also multiply V 2 times. So we say 18 times 18 automatically will have 324. While V times V automatically will give us V squared. In conclusion, we say 324 V squared. So we'll be using this to solve our problem. So we say 18 times 18 is 324, while V times V will have V squared over, what we have here? We have 3 ohms. On this note, ladies and gentlemen, we say power A will just be equal to 324 divided by 3, and we have 108. V squared all divided by ohms automatically we give us watts. So we already have our answer for power A. And power A automatically will just be equal to 108 watts. On this note, we'll be finding power B. So power B will be equal to V squared or resistor B. According to our formula, called the electric power formula that was derived from the Ohm's law. On this note, ladies and gentlemen, we say power B will be equal to, we already have our volt, and our volt automatically will be 18 volt. Parenthesis closes all raised to the power 2. Remember, over resistor B. We have resistor B, and resistor B number is 6 ohms. So we have 6 ohms here. Power B now will be equal to the same thing applying. 18 times 18 is 324. V times V give V squared over 6 ohms. On this note, ladies and gentlemen, we'll be looking at this problem to solve. Based on this problem today, ladies and gentlemen, we say power B. On our power B now to solve, we say power B will just be equal to 324 all divided by 6. Automatically we have 54. And V squared all divided by ohms will automatically get watts. So ladies and gentlemen, we already have power A and we already have power B. And we'll be solving for power C. Under power C, we have our formula. Power C will be equal to V squared or resistor C. Remember, the same thing apply. So we say power C will be equal to the volt, which is 18 volt in the parenthesis. Parenthesis closes all raised to the power 2 over what we have, resistor C. So resistor C now will definitely be equal to 9 ohms. So on our resistor C we say 9 ohms. So power C will be equal to, we say 18 times 18, the same thing apply is 324, and V times V will give us V squared over 9 ohms, ladies and gentlemen. Based on this, we say 324 divided by 9, power C now will just be equal to 36. For V squared, all divided by ohms, automatically we have watts. So ladies and gentlemen, we already have power A now, we have power B, and we also have power C, which is the power dissipated by each resistor. So we want to find our total power now, which is power B. So in order to find our total power, our formula says the total power will be equal to power A plus power B plus power C. The combinations of the following answers for power A and power B and power C in order to solve our problem to get our total power. So in our much, ladies and gentlemen, we say the total power will be equal to power A, answer is 108 watts, plus power B is 54 watts, plus power C is 36 watts. On this note, ladies and gentlemen, our total power here will be equal to 108 watts plus 54 watts plus 36 watts. If we add all, automatically we have 198 watts. Ladies and gentlemen, this is our answer for today. I remember one of the greatest physicists who also made a contribution to electric circuit today. It was Jean Pascal Joules. He introduced the Joule law, and the Joule law states that the quantity of heat gain is directly proportional to the square of the current, the resistance, and the time the current is maintained. That is the Joule's law. Ladies and gentlemen, thanks for joining me on this physics journey. In practicing, you push the limit, stay curious, and learn across those derivatives. Always remember that physics is a fundamental science that deals with the basic laws of nature. Don't forget to like, share, stay tuned, subscribe, and comment in the comment section. Once again, I'm B. Bomaser Jr., popularly or commonly known as Sketchy, the all-time record breaker. Thank you.